Over the years, people have uncovered bizarre occurrences in our deserts. From peculiar sinkholes that devour everything in their path to mysteriously balanced rocks, these arid landscapes hold countless mysteries. Join me as I count down some of the strangest phenomena happening in the desert. The sailing stones. Imagine standing in California's Death Valley, one of the hottest and driest places on Earth, and witnessing a massive boulder gliding across the desert floor. It might sound like something out of a sci-fi movie, but it's entirely real. This eerie phenomenon takes place in Racetrack Playa, a flat, dried-up lakebed surrounded by rugged mountains. Here, both small and large rocks, some weighing hundreds of pounds, mysteriously move across the barren surface, leaving long, winding trails behind them. These sailing stones have puzzled scientists and visitors for decades. For years, their movement was shrouded in mystery, sparking wild theories about magnetic forces, supernatural activity, or even extraterrestrial intervention. However, researchers eventually uncovered the secret behind this natural marvel. During the cooler winter months, a rare combination of conditions occurs. Thin sheets of ice form overnight on the lakebed, and as the ice begins to melt under the morning sun, it creates a slick surface. Add in just the right amount of wind and these rocks are gently pushed across the ground, gliding as though propelled by an unseen hand. Despite their slow pace, moving at about 5 meters per minute, the sight of these rocks in motion is both strange and mesmerizing. The desert glow. If you venture into the Arizona desert under the cover of night, you might stumble upon an otherworldly spectacle, a glowing desert. This natural phenomenon is thanks to two fascinating sources of bioluminescence and fluorescence that light up the landscape in unexpected ways. First, certain local mushroom species in the desert emit a faint glow in the dark. These bioluminescent fungi create a mesmerizing and eerie ambience, their soft light casting an ethereal glow across the sand. But the show doesn't end there. Shine a UV light at one of the desert's local inhabitants, the bark scorpion, and you'll witness a brilliant transformation. These scorpions glow a vivid blue-green under ultraviolet light due to fluorescent chemicals in their exoskeletons. This combination of glowing fungi and fluorescent scorpions makes Arizona's desert a surreal and enchanting place after sunset. For a nighttime experience unlike any other, head out to the rural parts of this remarkable state. With the stars above and the desert glowing around you, it's an adventure that feels straight out of a dream. Flash floods. It may seem surprising that deserts, known for their dryness, experience flash floods. However, flash floods are common and can be dangerous in these regions. The main reason is desert soil, which is dry, compact, and unable to absorb water. When rain does fall, it quickly runs off, often leading to sudden flooding. The topography of many deserts further amplifies this, with steep gullies or arroyos acting as natural funnels for the water. As rain flows through these channels, it gains speed, intensifying the flood. Additionally, desert rainfall is often sudden and intense, with short bursts dumping months' worth of rain in hours. This rapid deluge overwhelms the landscape, triggering flash floods. So, despite their dry conditions, deserts can unexpectedly experience the powerful and dangerous force of flash floods. The Sahara and Hurricanes. At first, it may seem odd to link hurricanes, known for their heavy rain, with the Sahara Desert, one of the driest places on Earth. However, the Sahara plays a crucial role in the formation of hurricanes in the Caribbean and North America. The key is the contrast between the Sahara's hot, dry air and the cooler, wetter conditions along the West African coast. This difference creates a powerful band of high-altitude winds called the African Easterly Jet, AEJ. The instability of these winds often triggers clusters of thunderstorms in the region. As these thunderstorms develop and organize, they can transform into tropical cyclones as they move westward across the Atlantic. The AEJ drives these storms, and when conditions such as warm ocean waters and low wind shear are favorable, they can strengthen into hurricanes. While not all hurricanes originate from this process, many of the most destructive storms trace their roots to the Sahara's weather patterns. It's a fascinating reminder that even the driest deserts can influence some of the planet's most intense weather. The Eye of the Sahara. In the Western Sahara Desert of Mauritania lies the Eye of the Sahara, or the Richat structure, a captivating natural wonder that spans 40 kilometers, 25 miles, in diameter. This massive geological formation resembles a giant bullseye etched into the desert floor. While local nomadic tribes have long been aware of its existence, the Western world only became acquainted with it in the 1960s. It was during NASA's Project Gemini that astronauts first spotted the eye from space, using it as a landmark during their missions. Its distinctive concentric rings make it easily recognizable when viewed from above. Though its appearance suggests it may have been intentionally carved, the eye's origins are entirely natural. Initially, scientists believed it was the result of a meteor impact due to its circular shape. However, further studies revealed no signs of an impact. Instead, geologists now believe the structure was formed through erosion, with layers of rock being worn away over millions of years to create its unique, circular shape. The Eye of the Sahara remains a fascinating and mysterious landmark in the desert. Dust storms. Dust storms are among the most iconic and frequent phenomena in deserts. These storms occur when powerful winds lift sand and fine particles from the ground, creating massive walls of dust that can reach heights of up to 1.6 kilometers, 1 mile. While dust storms can occur in various regions, they differ in intensity and form depending on the location. In the Sahara Desert and the Sahel, for example, the haboob is a particularly intense type of sandstorm. Driven by strong winds from weather fronts, these storms create towering waves of dust that resemble a dusty tsunami, sweeping across the land. In the Arabian Peninsula, another type of dust storm called the samum is common. The samum is a hot, dry wind laden with dust, and its temperatures can exceed 54 degrees Celsius, 129 degrees Celsius, earning it the nickname poison wind due to its ability to cause heat stroke and severe health risks. Dust storms aren't confined to deserts. One of the most devastating dust storms in history occurred in the United States during the Dust Bowl on April 14, 1935, Black Sunday. The storm displaced an estimated 272,000 tons of topsoil, causing widespread deaths, migrations, and significant economic losses. The Dust Bowl left a lasting cultural impact, inspiring folk songs that captured the hardships faced by many Americans. The hum of the desert. For over 800 years, a strange, eerie sound has echoed through the Sahara Desert, often described as a hum, groan, or low moan. This noise, which can reach up to 110 decibels, loud enough to be heard from miles away, has puzzled humans for centuries. Early explanations ranged from ghostly encounters to the influence of demons, but modern science has finally uncovered its true source. The sound is caused by sand avalanches, specifically in singing sand dunes. In the late 19th century, scientists began investigating this phenomenon and discovered that certain conditions must be met for the sound to occur. The sand must be dry, well sorted, and able to shift during avalanches down a dune slope. However, the mystery deepened when later studies revealed that the sound's frequency isn't determined by the size or shape of the dunes, but by the diameter of the sand grains. In 2010, researchers at the Laboratory for Physical Statistics in Paris recreated the process in the lab. They found that as sand layers slide down the dune, air cushions form between them. The weight of the avalanche pushes the trapped air outward, causing vibrations that generate the hum. The phenomenon continues to fascinate scientists and visitors alike. Desertification. Desertification is the process in which deserts expand, a phenomenon that has accelerated in recent years due to human activity and environmental changes. It occurs when the land's biological potential is diminished, transforming once fertile areas into barren landscapes. While deserts are naturally arid, desertification intensifies the process, making the land increasingly uninhabitable. Typically, desertification happens after prolonged droughts in arid and semi-arid regions, which drain the soil's productivity. Over time, the soil becomes nearly dead, incapable of supporting plant life. Vegetation plays a critical role in preventing soil erosion and runoff. Without it, the soil becomes vulnerable to wind and water, which accelerates the desertification process. Human activities have significantly contributed to this issue. With over 2 billion people living in at-risk drylands, activities like logging, intensive farming, cattle grazing, and mining are depleting the land's resources. Climate change has also worsened the problem, with rising temperatures and shifting rainfall patterns making these regions even more fragile. Combating desertification requires efforts such as sustainable farming, soil restoration, increased vegetation, and improved water management. However, these efforts need substantial financial investment and political commitment. Without significant action, desertification could become an even greater global challenge. Dust devils. Despite the name dust devil sounding ominous, these phenomena are generally harmless, though they certainly make for an intriguing spectacle in the desert. Dust devils are short-lived whirlwinds that can range from small, barely noticeable columns to massive funnels over 10 meters wide and up to a kilometer in height. These spiraling columns of air form when a pocket of hot air near the ground rises quickly through cooler air above it, creating an updraft. If conditions are right, this updraft starts to rotate, intensifying the spinning effect until it becomes self-sustaining. Once fully formed, a dust devil acts like a funnel, pulling sand and dust upwards to create a chimney-like structure that spirals both upward and outward. For a dust devil to form, 3 key conditions must be met: a flat, sandy surface for consistent rising hot air, clear or lightly cloudy skies to allow for enough solar energy to heat the ground, and a significant temperature difference between the hot air near the ground and the cooler air above. Additionally, calm winds are needed, as strong winds can disrupt the spinning effect, causing the dust devil to collapse. Dust devils are not exclusive to Earth. NASA's Viking probes have captured similar phenomena on Mars, where they are often larger and more powerful. Though these Martian dust devils can pose risks to equipment, they can also help clear dust from rovers, improving their performance. The Atacama Sinkhole. While deserts are typically stable and predictable, the Atacama Sinkhole is a rare and unexpected geological event. In August 2022, a massive sinkhole suddenly appeared in the Atacama Desert, one of the driest places on Earth. Spanning 36 meters across and plunging 200 meters deep, it is large enough to engulf the Arc de Triomphe in Paris. Located at the Alcaparrosa copper mine, the sinkhole's formation surprisingly did not affect any personnel, equipment, or infrastructure. Since its appearance, the sinkhole has remained stable with minimal growth, but the cause and potential risks remain uncertain. Chris Suniga, mayor of nearby Tierra Amarilla, believes mining activities at the Alcaparrosa mine may be linked to the collapse. He has urged officials to investigate whether mining operations contributed. David Montenegro, head of Chile's National Geology and Mining Service, suspects water accumulation at the sinkhole's base may have played a role, especially given the nearby mine's wastewater pumping operations. Concerns persist that more sinkholes could form in the area, threatening public safety. The situation is complicated by political and economic factors, as the Alcaparrosa mine is owned by Lundin Mining Corporation, a Canadian company. Chile's President Gabriel Boric has expressed concerns about overexploitation, but legal actions are still ongoing, leaving the future uncertain. A mirage. If you find yourself stranded in a desert, searching for water to survive, you might encounter a natural optical illusion known as a mirage, which can deceive you into thinking you've found water when there is none. A mirage typically appears as a shimmering pool of water in the distance, often resembling a lake or pond. However, this water doesn't exist. Mirages occur due to differences in air density caused by temperature variations in the atmosphere. In deserts, the air near the ground is much hotter than the air above it, causing light rays to bend as they pass through the layers of air. This bending reflects the sky above, making the ground appear like a body of water, especially since water often mirrors the sky. The shimmering effect is caused by convection currents of hot air, creating the illusion of a distant lake or road covered in water. Mirages aren't limited to deserts. They can occur on highways during hot days and even in polar regions, where ice and snow can create similar illusions. One famous example, Fata Morgana, can distort objects like ships and islands, making them appear closer, upside down, or distorted. While mirages are fascinating, they can also be dangerous, especially in extreme conditions. Always exercise caution and wait for better visibility before continuing your journey. Desert locusts. Desert locusts are among the most destructive pests on Earth, causing devastation to crops and livelihoods. Known for their mass migrations, these insects have been a threat to agriculture since biblical times. Although desert locusts are technically a type of grasshopper, they differ significantly in behavior and appearance. Normally solitary, they feed on local vegetation without causing much harm. However, under conditions such as droughts or heavy rains, locusts breed and release pheromones that trigger social behavior and physical changes. This shift turns locusts into large, gregarious swarms, with some groups containing up to 80 million individuals. Each locust can consume its body weight in vegetation daily, and a single swarm can devour enough crops to feed 35,000 people. The swarms devastate farmlands and threaten food security in affected regions. Compounding the problem, locusts reproduce quickly, with new generations emerging every 8 weeks, potentially multiplying the population by 20. In 2020, a swarm in East Africa and Yemen caused an estimated $8.5 billion in damages. Locust outbreaks often occur in remote areas, complicating efforts to deliver aid and manage the crisis, especially in conflict zones. Despite ongoing efforts, locust swarms remain a persistent threat, necessitating more resources for prevention and control. Oasis. Surviving in a desert's harsh conditions can seem nearly impossible, yet there exists a remarkable phenomenon known as an oasis that has allowed human life to thrive in otherwise barren landscapes. An oasis is a fertile area in a desert or arid region, supported by a natural water source such as a spring or underground reservoir. These water sources are crucial lifelines in deserts, providing essential resources for both human populations and wildlife. In many desert communities, oases have long been relied upon, with wells tapping into ancient underground reservoirs. The Sahara Desert, the largest desert on Earth, contains many such reservoirs that support over 90 major oases. These oases are vital to nomadic communities, which have historically journeyed from one to another in search of water, a practice that continues today. Oases are also fertile areas for agriculture, where crops can thrive. Date palms are commonly planted as the first trees in oasis farms, providing not only a source of dates, but also acting as natural windbreaks, shielding other crops from the desert winds. In addition to dates, other fruits such as figs, apricots, olives, and peaches are grown, creating patches of greenery amid the desert's expanse. Famous oases like Al-Hassa in Saudi Arabia and the Hakina Oasis in Peru have long served as agricultural hubs and cultural landmarks, supporting civilizations and enriching the desert's otherwise barren landscape. Sand dunes. When you think of a sand dune, you might envision a vast, immovable mound of sand. However, sand dunes are dynamic, constantly shifting and reshaping the desert landscape while supporting surprising amounts of life. Sand dunes form from the erosion of rocks, which break down over time into fine particles transported by wind, water, or ice. While much of the sand eventually ends up in the sea or on beaches, a significant amount accumulates in dunes. The composition of sand is primarily silica or quartz, although it can vary by location. The size, color, and texture of sand grains can reveal their origins and travel history. Smaller grains are typically those that have traveled farther. Dunes form in areas with loose, wind-blown sand and minimal vegetation. Wind is crucial for moving the sand, and obstacles like rocks or plants cause the sand to settle, gradually building up the dune. Sand moves in 3 primary ways: saltation, bouncing grains; creep, collisions with other materials; and suspension, grains lifted into the air. The strength and direction of the wind influence dune size and shape. Despite their shifting nature, sand dunes support unique ecosystems, with desert plants and animals adapting to the ever-changing environment. However, sand dunes can pose risks to human settlements, especially in regions like China, where dunes advance rapidly, threatening infrastructure and agriculture. Efforts to stabilize dunes are ongoing, but their movement remains a challenge. Precariously balanced rocks. Deserts are home to many natural wonders, but few are as captivating as precariously balanced rocks, PBRs, which seem to defy the laws of physics. These formations consist of large rocks perched atop smaller ones, creating an illusion of gravity-defying balance. While some are artistically created, most are formed by natural forces, offering insights into the landscape and the powerful forces that shape it. A famous example is Balanced Rock in Colorado Springs, a 290-million-year-old red sandstone boulder weighing 600 tons. Perched on a narrow slope, it seems ready to topple, yet remains securely in place, showcasing nature's ability to craft seemingly impossible structures. Goblin Valley State Park in Utah is another iconic location, home to thousands of mushroom-shaped PBRs called hoodoes, which add to the park's surreal beauty. PBRs are formed in different ways. Some were left behind by retreating glaciers, while others result from erosion carving rock faces into curious shapes. Interestingly, some are sturdier than they appear, connected by a thin spine of rock. Scientifically, their location and formation reveal that the area has remained relatively undisturbed, providing valuable geological insights. Despite their scientific value, PBRs are often at risk due to human interference, with some people attempting to push them over. Such actions threaten both environmental preservation and research. In Zimbabwe, balancing rocks symbolize resilience and national pride, appearing on currency during the country's economic crisis. These rocks continue to embody both natural and cultural significance, highlighting the delicate balance between nature and human impact. That's all for today. Thank you so much for watching, and if you enjoy the video, please let us know by clicking the like button, do share, write a comment, and don't forget to subscribe.